Docker, what and why for beginners? Docker comes into the picture as an open source project in March 2013. It is written in Go programming language. Big companies like AWS, Google Cloud, Azure, Rackspace, and many more use Docker as their underlying container service. Docker is a platform as a service product and is a way to have operating system level virtualization. Using Docker, you can build and deliver your software as packages. The idea behind that is you can package your application and its dependencies in a virtual container. In Docker, we call these packages as containers. Having a package or a container allows you to isolate your application completely from your host environment. Application isolation. One of the major advantages of Docker. Just think you are developing a web application and it highly depends on PHP 7.2, Apache, and MariaDB 10.2 as the DB service. If someone needs to use your application, they need to set up the environment with the exact versions of PHP, MariaDB, and Apache. Maybe they need to remove the existing versions of PHP or MariaDB in their environment. So it can cause another application to crash. Docker is the solution. Think you have a bucket. We call this bucket as a container. You put all your application code and all the dependencies into this bucket. Now you deliver this bucket as your software. Now if someone wants to use your application, they can take your bucket and start use. But for that, they need Docker to be installed in their machines. They do not need to worry about your application dependencies anymore because all the dependencies are there in your bucket. It doesn't matter what kind of environment they have, what is the operating system, what are the existing PHP versions or MySQL versions, doesn't matter. Because of this bucket or the container, as a developer, you don't need to worry about the client's environment when you develop the application. Also, as the client, they don't need to worry about your application dependencies anymore. This is a well-known headache for millions of developers today. It works on his machine, but not in mine. The story is like this. Think you are a developer and you create a build and pass it to the QA team for testing. Here the fight begins. QA comes and tell you, hey man, I installed the build, but the feature A is not working. This should be a huge bug. Developer, no, can't be. See, it's working. See man, it's working in my machine. Okay, the hard guy comes, project manager. Guys, what's going on? Fix this and come back to me within the next hour. You are screwed. You spent a lot of time and finally find the root cause. Issue is with the QA's machine. She has Ubuntu 18.04 in her machine, while you have Ubuntu 16.04 in your machine. So one of your application dependencies does not function as expected in Ubuntu 18.04. So that causes the error. The ideal solution is you have to develop again that feature in a way that it supports for any environment. It takes a lot of time and definitely it's a headache. According to the bucket example we talked earlier, you can just use Docker and get rid of these kind of problems. Docker basics. As a beginner, it is important for you to have an understanding on these points. Architecture, Docker engine, Docker client, Docker registries, and the main Docker objects like images and containers. Docker architecture. This diagram is from the official Docker website. There are three major components in the architecture. Number one, the client. We will talk about this later. Number two, the Docker host. Docker host is the machine or the computer that you install Docker. That is where the Docker service is running. Number three, registries. This is where you store your images. We will talk about this later. Docker engine. This part of the architecture diagram represents the Docker engine. Docker client and the Docker host are the components of the Docker engine. Docker engine is the one who allows you to develop and run Docker applications. And it is a client-server application. It has three major components: Docker daemon, REST API, and Docker client. The main component of Docker engine is the Docker daemon. This is a background process and it always listens for Docker API requests. Or one can say that this is the server part of the Docker engine. The second component of Docker engine is REST API. This API is exposed to the outside world. It helps other applications, I would say third-party applications, to interact with Docker daemon. So you can manage Docker objects like containers, images, and volumes. This API is accessible via a HTTP client. The third component is Docker CLI, also known as the Docker client. This is a CLI interface. This also allows you to interact with Docker daemon. As a developer, most of the time you will work with Docker client. Docker registries. I believe that you all have heard of GitHub. GitHub is a repository for your application code. Similarly, Docker registries are the repositories for your Docker images. Docker Hub is the well-known official repository for Docker images. And also, if you wish to have your own repositories, that also can be done. Docker objects, images and containers. This is very important to understand. When you develop an application, you will work with these very frequently. Image. Image is the blueprint of a container. And this is just a binary file. We write Docker files to create or build images. Container. Container is a running instance of an image. Container is the encapsulated environment for your application, and it is only allowed to access the resources that are defined in the images. You can build or create images using a container as well. Let's see this diagram. This is how it happens. First, we write a Docker file, and then we build an image using the Docker file, and then we spin up a container using that particular image. Once you have your container, you can add many changes to that and you can commit it as a new image. In future, you can use that new image to create more containers. That is all for this tutorial. I'll give you a hands-on experience in next one. Thank you for watching.